Okay, good morning class. So at this point we're looking at the grade 12 probability. We did a revision of the grade 11 section of work, then we moved on to the grade 12, which is the counting principle. At this point we had to do exercise 2 of the even numbers, correct?
Yes, sir.
Alright, I gave you that for homework. So I'm going to do some quickly. You just check the speaker is, the mic is on. So in our last lesson, when I checked, the mic was actually off. So it was a quiet lesson. Okay. As per normal, you guys didn't talk to me either. But in that video, I was doing myself, I couldn't hear myself. I had to re-record that lesson. Okay. Sure, yes. But anyway, consider the word oranges. The question says, in how many? Oh, I'm skipping number 2. How was I now feeling? Right, let's take a step. Okay. Find the number of ways that the judge can award first, second and third place in a competition with 10 contestants. So how many bids would I draw here? 10. You all agree with that? How many placements do I have? 3. So it's going to be 3. How many options do I have? 10. Then 9. Then 8. Which is the same as 10 factorial over 10 minus 3 factorial. Which is 10 factorial over 7 factorial. Gives you 703. You all agree with that? Let's carry on. Question 4. Considering the word oranges, how many 7-letter word arrangements can be made if the letters may be repeated? So the letters may be repeated. So 1, 2, 3, 4, 5, 6, 7. 1, 2. Okay. So how many options do I have for the first bid? 7. And the next one? 7. So since the letters may be repeated, it's going to be 7 to the exponent 7. Gives you 823,000. 500. Okay. Let's look at B. How many similar word arrangements can be made if the letters may not be repeated? So that's going to give you 7, then 6, 5, 4, 3, 2, 1, which is the same as 7 factorial. Okay? Gives you 504. People, if you can see it straight without drawing these bids, no problem. You can go straight into that as well. Okay? See? How many 4-letter word arrangement can be made if letters may be repeated? So it's 1, 2, 3, 4. How many options do I have here? 7, 7, 7, 7. So it's going to be 7 to the 4. 7 to the exponent 4 gives us 2,401. And then the last one, D. 4-letter words in letters may not be repeated. So it's going to be 7, 6, 5, 4, which is the same as 7 factorial over 7 minus 4 factorial. Gives you 810. You all agree with that? Okay. 6 has in store for us. Number 6, the digits 0, 1, 2, 3, 4, 5, 6, 7 and 8. What is not there? 9. So how many digits are there? There are 9 digits, okay? I used to make 4-digit codes. So in the first case, 6A. How many different codes are possible if the digits may be repeated? How many bits do I draw? 4. How many options do I have here? 9. Then may be repeated. 9. Then 9. Then so in other words, this is 9 to the exponent 4. Why? Because it's 4-digit code. Okay? So it's 6561. Then look at B. How many different codes are possible if the digits may not be repeated? How many options do I have? 9. Then 8. Then 6. Which is 9 factorial over 9 minus 4 factorial. Again, people, if you can see that's going to go into that, you could have done it without it. Okay? 9 factorial over 9 minus 4, which is 9 minus 4 is 5 factorial. Or you could have just typed in the calculator 7 times 8 times 9 times 6. Okay? We have also given you an answer of 3024. Okay. See how many codes are numbers that are greater than or equal to 4,000 that are exactly divisible by 2. The digits may be repeated. So if the number is a 4-digit code and it's greater than 4,000, so remember the numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8. So if it's greater than 4,000, how many options do I have here? How many options do I have in the first bit? Can the first number be 0? No. Can it be 1? No. 2? No. 3? No. So if the first number is 3, it's going to be 3,000 and something. If the first number is 0, it's going to be in the hundreds. If the second number is 1, it's going to be in the 1,000s. Does it make sense? So this number, the first number, can only be a 4, 5, 6, 7 or 8. So how many options do I have? 5 options. Not so. Then another condition is given that it must be divisible by 2. So if it's divisible by 2, can the last number be 0? Yes. Can it be 1? No, because that will be odd. Can it be 2? Yes. Can it be 3? No. Can it be 4? Yes. Can it be 5? No. Can it be 6? Yes. Can it be 7? No. Can it be 8? Yes. There's 1, 2, 5 options. The letters may be repeated. So how many options do I have for the second bit? No, I can choose any of these options now. Not so. So if you had used 4 here for 4,000 and something, you can use 4 again there and there. So the letters may be repeated. So how many options do I have for the second bit? 9. For the third bit? 9. So this is where a case where we can't go with 4 factorial or in this case 9 factorial over anything. So this is straight multiplication here. So that would simply be 5 times 9 times 9 times 5. It gives you 2,025. Now for D, there's a twist here. We are told that how many codes are numbers that's greater than 4,000, and it is exactly divisible by 2. So what's the difference between the two? In D, it must be greater than 4,000. However, in C, it could be 4,000 and greater. So how many values are counted here in year 4? They are only omitting which value? 4,000 is. So how many codes are 4,000? 1. So in other words, is this 1 less than 2,500? 2025? 2020. Okay, that is a good sign. Any confusion there? I think that was the last sum, no? And that's where we stopped. Is that correct? Can I give you more homework on this? Huh? No. Okay. So I know in the last, when you guys were in the class, I did the first one, no? But the last video I just omitted it, and I said I'm going to start again at this point. So now we're looking at example 10. And example 10 is on page 313. Example 10 is on page 313. Here we are told arrangement of objects in a row. Okay. In how many ways can 3 boys and 2 girls sit in a row? 3 girls and 2 boys. So now other condition is set on that. So how many people do we have here? 5. So we have 1, 2, 3. 5 bits for 5 seats. Okay? So how many options do I have for the first seat? 5. Second seat? 4. Then 3. Then 1. So in other words, that is 5 factorial. No, that's not 7. That is 120. Right? Just check here. 5 factorial. That's 5 times 4 times. Yeah, it's 120. 6 factorial is the next one. 760. Okay. Let's look at B. In how many ways can they sit in a row if a boy and his girlfriend must sit together? Around, no? Yeah, but anyway, that's how it goes. So what we do is, we put the girl and the boy together, the girlfriend and the boyfriend. Totally around. I don't actually want to show you how to do this, no? It's in the sum. Okay. So they're together. Okay. So think about it. This can happen as girlfriend, 1, 2, 3, 4, 1, and the boyfriend. This can happen in there. Okay. The girlfriend and boyfriend would be sitting there, not so, but together. You all agree with that? Then the girlfriend and the boyfriend can be sitting there together. And the girlfriend and boyfriend could be sitting there. Not so. Alright. Also, they could have swapped the girlfriend then the boyfriend then the girlfriend. Not so. So if you look at this, it's actually going to be 2 factorial because the girl and the boyfriend can swap. Not so? So it will be 2 factorial times. That combination is 1, 2, 3, 4 factorial ways. Can you see that? Besides, the girlfriend and the boyfriend can swap here. These 3 can swap again. Not so? And those 3 can swap. And those 3 can swap. And those 3 can swap. That is why that can happen 1, 2, 3, 4 times. That's why it's 4 factorial. Does it make sense? Okay. So do you have about the girlfriend and boyfriend? Okay, so we're saying that if we look at if the girlfriend and boyfriend must sit together, okay, they can occupy the first 2 seats, not so. Or, but besides them occupying the first 2 seats, these 3 remaining people can interchange. They can also be swapped around. So that must also be accounted for. Can you see that? Then, the girlfriend and boyfriend can occupy the second and the third seat, whilst the others can still swap around. In the third case, girlfriend and boyfriend again in seat 3 and 4, or in seat 4 and 5. That can be the case. Can you see that? Then I said that that can happen how many ways? 1, 2, 3, 4 different ways. So it's 4 factorial. But the girl and the boy can also interchange. So how many options do I have here? 2, then 1. 2, then 1. And so on. So if I got 2, then 1, what is that? Is that not 2 factorial? Not so? There we go. So now, how are we going to draw this scenario all the time? No, we don't have time for it. So what we do is we say, okay, we read it again and we say, in how many ways can they sit in a row if a boy and his girlfriend must sit together? So, we put the girl and the boy together and we bind them. And they become one bid. Now, can you see that? So, that bid can happen there, or there, or there, or there. Can you see that? That's why I bind them together. Okay? So they can sit in how many ways? 2 factorial ways. Then I count them as one bit. There's 1, 2, 3, 4 options now. Can you see that? So it will be 4, then 3, then 2, then 1 option. Can you see that? So in other words, that is going to be 4 factorial. That's going to be 2 factorial times 4 factorial, which is 48. Okay. In the textbook, there's another explanation to it. If you don't understand, you can refer to the textbook again in your own time. Okay. But is there anything that you're confused about here at this point? No? Alright, let's look at C. C. Let's go with blue. C. How many ways can they sit in a row if the boys and the girls are each to sit together? The girls and the boys are each to sit together. So, we have 1, 2, 3, 4, 5. So what does that mean? That means to say I must bind all the boys. You can see here, the boys will sit together. B, B, B. And then the girls. So G, G. You all agree with that? They're together. Not so. So what do we do now? We bind the boys. So how many ways can the boys be arranged? How many options do I have here? 3. Then? So what is that? 3 factorial. The girls can be arranged now. 2 factorial. But can the girls then not sit first, then the boys? Because then you could have had G, G, B, B, B. That could also be a case. Not so. So what is that? Times? How many ways can this be rearranged? 2 ways. 2 factorial. Okay. So it's 3 factorial times 2 factorial times 2 factorial, which is 24 ways. Okay. That's not what you need. Alright. Any confusion here? No? Carry on with example 10 on page 313. So let's look at D. We're still busy with 3 boys and 2 girls, no? That's still the case. Just cut it so that the board is just not full of writing or questions. Right, in D. In D we are told, in how many ways can they sit in a row if just the girls are to sit together? So how many bits do I draw here? How many bits do I draw here? 5. So if the girls are to sit together, how many girls are there? 2. So what do I put here? Girls, go. Not so. Then what do I do with that? I bind them. So that's a condition needs to be made. So you write down the calculation. What do you think the calculation would be? So what do you think this calculation is going to be? This would be 2 factorial times 4 factorial. Yes, why? So that by binding them makes them 1 bit. So that's going to be 1, 2, 3, 4. So it will be 4 factorial. You will understand? Right. Sheila, boring today that you're falling asleep here? Why are you falling asleep? How does that feel? I feel bored and boring. Okay, I'm moving too slow, you say. Okay, I'll pick up the person. Right, number 3. C. Sorry. How many ways can they sit in a row if just the boys are to sit together? How many bits do I draw? 5. So what do I do? With B, B, B. And what do I do with them? Bind them. So do the calculation quickly. So what would this be? 3 factorial times 3 factorial. And 3 factorial times 3 factorial is 36. And 2 factorial times 4 factorial? Sorry? Look at the last one. If in how many ways can they sit in a row? If the boys and girls are to alternate, what does that mean? Huh? You must say the girl then the boy, and so on. That's all. So how many birds do I draw here? 5. Can I start off with the girl? Why not? Somebody saying yes, so let's do. Girl, then what must this be? And then this must be a girl, and this here, and this one. Are you alternating? No. So you can't actually start off with a girl. There's not enough girls to alternate. Okay. So let's go. It must start off with a boy, then a girl, then a boy, then a girl, then a boy. Okay. So what will the calculation then be? How many options do I have for this here? That would be, how many options do I have in the first case? 3. Then 1, which is 3 factorial, not so? Times the options for the girls. It's going to be, how many options do I have here? 2, then 1. It's 2 factorial. Which is, I think we did the calculation already. 3 factorial times 2 factorial. Can I give you? Okay. Cool way of counting, huh? Let's see. So exercise 3, we're going to do the odd numbers quickly. And this is out of exercise 3, and this is on page exercise 3 on page 3, 15. Right, I'm going to pause the video at this point. I'm going to give you a chance to do all the odd numbers quickly, okay? I'll give you 10 minutes.